So most multiplication models, we would write the setup equation where the second number would have that per part in it. There is an exception though. So typically when we write a multiplicative comparison problem, we would not write the setup in that same way where we have like this many groups or rows and then this many objects per row or objects per group or objects per choice. So the other models that we've done, they have that set up for multiplicative comparison. This model that's sometimes used, it looks a little different. And so it's going to be the number that you have, the number of objects that you're talking about, times however many times more, right? So to give you an example, this says Billy has 5 toy trucks. Tommy has 3 times as many trucks as Billy. How many trucks does Tommy have, right? So this is not like we have groups and then objects in each group or rows and then objects in each row. This is just, we're saying we're starting with a number of objects, and then this, in this case, this other kid has a certain number of times more than that. So for this particular problem, I would start with, we knew we had 5 toy trucks. So that's what Billy had. And then we know Tommy has 3 times as many or 3 times more. So we would literally write times more as the quote unquote units. And then that's going to tell us what the total is. In this case, the total would be in trucks. Or if you say toy trucks, that's fine too. And so one way that you would probably do this is with a number line, or you might do a strip diagram. So like you could draw like something that's supposed to represent trucks, but it maybe gets a little bit harder just because like you're drawing the individual trucks, and really we need to be like taking that whole group of trucks and making it that many times more, in this case 3 times more. So you could do it, but we're gonna stick with just number line. Again, your student is not gonna know how far out they need to go on their number line, right? We would know to start with 0 because we're not gonna have a negative number of trucks. But this is really similar in terms of the one that we did earlier with the number line. So we know we could start with 5, right? So let's go out that far. 1, 2, 3, 4, 5, right? And so I know that is what Billy has, right? And then we are saying Tommy has 3 times as many trucks as Billy, right? So far we just have 5 trucks. That's just 1 times as many, right? So if we were going to double that or do 2 times as many, we would do 5 more, right? So 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5 more would take us out to 10, right? And so that would be 2 times as many or 2 times more. And so for 3 times more, we'd do another 5. 1, 2, 3, 4, 5 more would take us out to 15. And again, for multiplication, we use big hops, right? And so then where did I end up? I ended up with 15. And so that's my answer here. For strip diagram, same idea, right? So usually when we do a strip diagram, we are used to like drawing one thing on top and one thing next to it, like comparing 2 things. Or we've got like a hole in the parts. That's not what we're doing here. So for multiplication, let's just start with what we have, right? So we started with the 5 toy trucks that Billy has, right? And then we're gonna like repeat that, right? So I'm gonna use a dashed line. You wouldn't have to, but just to kind of show like this is what we're increasing it by. I'm trying my best to make that roughly the same size. So that's another 5. And then so that would be 2 times as many, right? Because just the original 5 is 1 times as many, then 2 times as many, and then finally 3 times as many. So that would be a good strip diagram to show. And if you want to label those as 5s in there, you can. But I think it's good to note here, there is a really common student misconception that you may see. You could see it on your number line as well. So with either the strip diagram. So I think what a lot of students will end up doing as a misconception, they'll start with the 5 and they'll say, oh, okay, Tommy has 3 times as many trucks. And they'll say, okay, so let me do, here's 1, 2, 3 times as many. And so you're going to see a lot of students do that. Or on the number line, you might see them go out like saying this is 1 times, this is 2 times, this is 3 times, right? But that's not really correct, right? Because we have to count the original one, right? So the correct way to think of that is this is 1 times as many, this is 2 times, this is 3 times. Or on our strip diagram, the first one, right, is 1 times as many, right? So it's not saying you're starting with 5 and then doing 1 times, 2 times, 3 times. It's saying, well, the first 5 is 1 times as many, right? Then 2 times, then 3 times. But you can see like why a student would maybe do that. Like they'd say, oh, I start with 5 and then I do 3 times as many, so let me do 3 more. So it's a really common student misconception. So if done correctly, then we should have 5 and then 10 and then 15, right? So this 5 more makes 10, 5 more makes 15. In this case, that's 15 toy trucks.